First, starting out with solutions, defining what a solution is, and taking a look at some things that dissolve compared to other things that do not. Some terminology for you. Solute and solvent. A solute, that is going to be the thing that's in the smaller amount. A lot of times it's a solid, but it doesn't have to be. It can be a gas or it can be a liquid as well. Here it's showing you the salt. That's the solute, the thing being dissolved. Solute is the thing being dissolved, whereas the solvent is the thing that's doing the dissolving. Solvent, water, is the most common solvent. It's the thing that does the dissolving. An easy way to tell which is the solute and solvent. Solute is going to be the one in the smaller amount, where solvent is going to be the one in the larger amount. When something actually is dissolved, that means that it is broken down to its smallest quantity, so whether it's ions or as a molecule, and it's spread evenly throughout the solvent. So the solute is spread evenly. They cannot be separated by filtration. That's how you know something is truly dissolved. It can be separated by evaporation. That's where then your ions or your molecules are going to start clumping together again. But they cannot be separated through filtration. Here's some examples for you. Notice that solutes or solvents can be solids, liquid, or gases. The most common one we're exposed to is the solid that's dissolved in a liquid. But if you look down below here at some of these ones, steel. Steel contains two different solids, so we got carbon and iron. Both are solids. We still have a solute and a solvent. How do you know which is which? Remember, the one in the smaller amount is going to be the solute. So these are the ones in the solute. Dental amalgam, I don't think they use this anymore, but mercury, it's a liquid, and silver, which is a solid. Probably don't want a lot of mercury and tied up into your teeth. It's not a good idea. Okay, use this learning check as the did you watch it questions. So this is your did you watch it. Identify the solute in each. And the first one you're probably thinking, well, what the heck? They're in two different measurements. We got grams and we got milliliters. Remember the density of water, though. Density of water is 1 gram per milliliter. If you have 100 milliliters of water, that is going to be 100 grams of water. We're starting with 2 grams of sugar, 100 grams of water. Our sugar is the solute. Next one. We're mixing two different alcohols. We have ethyl alcohol and methyl alcohol. The one in the smallest quantity is going to be the solute. We have 30 milliliters of methyl alcohol as the solute. Next one. Again, you can think of this instead of 55 milliliters, 55 grams of water. So then the sodium chloride is the solute. And the last one, the oxygen, is the solute, if we look at air. Water is considered the universal solvent because it dissolves more things than anything else. The reason why it does this is because it's very polar. It has an uneven distribution of charges. So it is a covalent molecule, but it's very polar. So you can see here we have the partial negative charge on the oxygens. Then we have partial positives on the hydrogens. Opposites attract. So the hydrogen from one molecule is going to be attracted to the oxygen of another molecule. And then what forms that attraction between them is a hydrogen bond. Hydrogen bonds are the strongest of the intermolecular forces. So looking between different molecules, we have this hydrogen bonding, and it can be very strong. Water is extremely attracted to itself. And it's able to dissolve other things very readily because of these partial charges. For example, here's dissolving salt, just table salt, sodium chloride, in solution. So this picture is showing you what actually happens when you dissolve that sodium chloride. When you drop it in, you have this big honkin' structure. It's a whole bunch of sodium chloride formula units stuck together. And then the water comes in and starts breaking it apart. The oxygen showing you on this side is attracted to the blue ones, which are the sodiums. They have a positive charge. Then we have the hydrogens that are attracted to the negative, which is the chloride. It starts pulling this whole structure apart. So then what you're left with in the end is just dissolved ions. The reason why you can't see it any longer is because it's no longer this big honkin' square or cube, but you have just ions in solution, which you can't see with the naked eye. So we say it's dissolved. Another way to put it is that it's hydrated. So hydrated ions mean that water is completely surrounding the ion. Okay, then if we start looking at how well things dissolve, we can write it kind of like a reaction. But remember, it's not a true reaction, because a true chemical reaction, you have bonds breaking and bonds reforming. This is only breaking bonds. Bonds are not reforming. The water is written above the arrow because it's not, the sodium chloride isn't actually reacting with the water. The water is just breaking it apart. We'll call it a reaction, but recognize that we aren't actually having bonds breaking and reforming between the sodium chloride and the water. We're just dissolving. Starting with solid sodium chloride, water is written above the arrow because it's just a catalyst for the reaction of breaking apart the sodium and the chlorine. And notice now they're in aqueous solution, so the AQ separates the ions out. Why do some things dissolve and other things don't? Or you think of if you ever had to paint something, you have to use a certain kind of solvent to dissolve it. You know, if you get like an oily or oil-based paint, you can't just wash your hands with soap and water a lot of times. It won't come off. The water is just beating up and it feels kind of slick on your hands, that paint, and you have to use something else to dissolve it. It goes back, in this case, like dissolves like. So in other words, polar molecules are only going to dissolve other polar molecules. Polar means you have that uneven distribution of charges. One part of the molecule is going to be partially positive, while the other side is partially negative. Polar molecules will dissolve other polar molecules. They will also dissolve ionic compounds. So you saw that with the sodium chloride. Sodium chloride was ionic, so polar will dissolve ionic compounds. Polar and polar. Same with nonpolar. Nonpolar means it's an even distribution of charges. So you don't have this, positive and negative area going on. It's all even. Nonpolar will dissolve other nonpolar molecules. Again, let's use this learning check as the did you watch it. Taking a look at this first one. Lithium chloride is added to water. Why does it dissolve? The lithium ion, so it's a positive ion, which is it attracted to, the oxygen or the hydrogen? Remember, opposites attract, so the lithium ion is going to be attracted to the oxygen because of the partial negative. That weird looking S thing means partial. B, how about the chloride ion? Chloride ion is negative, therefore it's going to be attracted to the hydrogen because of the partial positive on the water. Remember, this is an ionic compound and it's being ripped apart by the water. It's being hydrated so that you only end up with ions in solution. The idea of like dissolves like, remember, polar will dissolve other polar, nonpolar will dissolve other nonpolar. Anything feeling kind of greasy is usually a nonpolar substance, so therefore it has to be dissolved by another nonpolar substance. Are you going to be responsible for identifying polar nonpolar? At this stage, no. You won't have to identify nonpolar. You will be told if things are nonpolar. Here's just giving you kind of a picture of what's going on between two polar substances. So we have water and we have methanol. So I'm just, you're not responsible for identifying methanol as polar, but it is. What's happening between them? Here, the first picture is just showing you what methanol looks like. We have this OH group. Anything with an OH group is an alcohol, and it is very polar. The OH group here is shown to you by the red and the white here. So the red's the oxygen, the white is the hydrogen. Then you see what the molecule water looks like. The last one's showing you the interaction. Notice that hydroxide, the OH group, is attracted to the water molecules. You get these hydrogen bonds that form between them. Here's a beautiful picture. These top ones are showing you water, which is polar. These bottom ones are showing you nonpolar substances. And this one is iodine, which is I2. Same thing here. Here you see nickel nitrate, which is actually ionic, with, again, a nonpolar substance. So they don't mix. So think of oil and water. Oil and water don't mix because water's polar. Any kind of vegetable oil or any kind of oil is nonpolar. Okay, so which of the following solutes dissolve in water and why? First one, it will because it's ionic. We have a metal, sodium, and then sulfate, your polyatomic ion. The first one's ionic, so it will dissolve in water. The next one, gasoline, I tell you it's nonpolar, therefore it will not dissolve in water. I2, which I showed you on the previous slide, that is nonpolar. Anything that's bonded to itself like this, if you see I2, Cl2, O2, those are all nonpolar substances. So something, two atoms bonded to themselves, the same atoms, they will always be nonpolar. And the last one, here we have a hydrogen, so hydrogen bonding is going to happen. So HCl will dissolve in water.